Are we completely alone in the deep space? Why is the cosmos so incredibly quiet? What if this terrifying silence is actually a survival strategy against something hiding in the dark universe? Welcome to Silence of Space. We tell the universe. Look up at the stars in the night sky. Our sun is just an ordinary star floating in the immense scale of the Milky Way. The Milky Way galaxy contains hundreds of billions of stars, and many of them host a beautiful planet in their orbit. But our galaxy is just a single drop in a much larger cosmic ocean. When we look further into the observable universe, we see trillions of galaxies scattered across the cold deep space. The true scale of the cosmos is entirely beyond human imagination. With so many stars and planets existing in the universe, life should theoretically be everywhere. The cosmos should be a crowded place, filled with advanced civilizations and lights. Yet, when we listen to the dark interstellar space, we hear absolutely nothing. This perplexing absence of signals, this deafening silence, is not due to a lack of cosmic real estate. Our universe is a place of staggering, mind-boggling scale, a vast tapestry woven with billions upon billions of galaxies, each a churning whirlpool of stars. When we look up at the band of the Milky Way stretching across a dark night sky, we are only seeing a tiny fraction of our own galactic neighborhood. The sheer numbers are beyond human comprehension. Our galaxy, the Milky Way, is home to perhaps 400 billion stars. 400 billion. Each one a roaring furnace of nuclear fusion, potentially a sun to a family of planets. If we expand our horizon to the limits of the observable universe, the scale becomes truly terrifying. We estimate there are over 2 trillion galaxies in the observable cosmos, each containing hundreds of billions of stars. The number of potential planets, of possible cradles for life, is a number so large it loses all meaning. It is a grain of sand on a beach that stretches for an eternity. The cosmos is not empty, it is a crowded, vibrant place, filled with the raw materials for life. The building blocks of organic chemistry, carbon, hydrogen, oxygen, nitrogen, are forged in the hearts of stars and scattered across interstellar space by the violent death of a supernova explosion. The universe has had 13.8 billion years to work its magic, to let life emerge and evolve. So where are they? This is the core of the Fermi Paradox. If the universe is teeming with planets, and life is a natural outcome of cosmic chemistry, then advanced, spacefaring civilization should be a common sight. By all rights, the Milky Way should have been colonized millions of years ago. We should see the unmistakable signs of astroengineering, perhaps Dyson spheres encircling stars, or vast generation ship fleets traversing the voids between the stars. We should detect their leakage radiation, their radio and television signals, a cosmic chatter filling the airwaves. Yet, the radio telescope arrays of SETI, the search for extraterrestrial intelligence, have listened for decades. They have pointed their sensitive dishes at thousands of stars, scanning millions of frequencies. And the result? A profound, unbroken silence. The only sound is the static hiss of the universe itself, the cosmic microwave background radiation, the faint afterglow of the Big Bang. For the longest time, one of the biggest question marks in this paradox was the number of planets. We didn't know if our solar system was a rare anomaly or a common occurrence. We didn't know if planets were freak accidents of planetary formation or a natural consequence of star birth. This all changed with the launch of the Kepler Space Telescope. Kepler's mission was simple yet revolutionary: to stare at a small patch of the Milky Way, a dense star field in the Cygnus constellation, and wait for a planet to pass in front of its star. Kepler didn't just find a few planets, it found thousands. It revealed that planets are not rare, they are ubiquitous. They are everywhere. Our galaxy, the Milky Way, has more planets than it has stars. Kepler showed us hot Jupiters, gas giants orbiting their suns in mere days, scorched, molten worlds, and vast, frozen worlds on the edge of darkness. But most importantly, it found Earth-sized planets, and it found them in the Goldilocks zone. This is the habitable zone, the narrow band around a star where it is neither too hot nor too cold, but just right for liquid water to exist on the surface. We now estimate there are 40 billion Earth-sized planets in the habitable zone of their stars in the Milky Way alone. 40 billion potential homes for life. And this was just the beginning. The James Webb Space Telescope, with its powerful infrared eyes, is now peering into the atmospheres of these distant worlds. It is looking for biosignatures, the unmistakable chemical traces of life, like oxygen, methane, and carbon dioxide. We are on the verge of finding life elsewhere, of answering the question, are we alone, in the affirmative. The universe is a fertile ground, a cosmic garden ready to bloom. The potential for life is staggering. The stage is set for a crowded cosmos. And yet, the silence persists. The contradiction is jarring. A billion potential voices, and not a single whisper. It was the summer of 1950 at the Los Alamos National Laboratory. Four brilliant physicists were walking to lunch, casually discussing a recent cartoon about flying saucers stealing trash cans. The conversation drifted to the mathematical probability of faster-than-light travel and the sheer vastness of the cosmos. Suddenly, the brilliant physicist Enrico Fermi stopped walking, looked at his colleagues, and asked a deceptively simple question that would haunt humanity for decades to come: where is everybody? This single question gave birth to what we now call the Fermi Paradox. It is the terrifying contradiction between the extraordinarily high probability of extraterrestrial life existing in the universe and the absolute lack of any evidence for it. The mathematical logic is utterly inescapable. Our Milky Way galaxy alone contains hundreds of billions of stars. Many of these stars are much older than our Sun. If even a microscopic fraction of these stars have planets, and a microscopic fraction of those planets sit perfectly within the habitable zone, there should still be millions of worlds capable of supporting life. To truly understand the weight of this silence, we must look at the Drake equation. Formulated by astrophysicist Frank Drake, this famous mathematical formula attempts to estimate the number of active, communicative extraterrestrial civilizations in the Milky Way. The equation multiplies the rate of star formation in our galaxy by the fraction of those stars that have planets. It then factors in the number of planets per solar system that have an environment suitable for life, the fraction of those where life actually appears, and the fraction where life evolves into an intelligent species. Finally, it accounts for the civilizations that develop the technology to release detectable signs of their existence into deep space, and the length of time they broadcast those signals. Even if we plug in the most incredibly conservative numbers into the Drake equation, the result is staggering. The math insists that the night sky should be alive with radio signals. We should be detecting the hum of alien machinery, the exhaust trails of interstellar travel, and the communications of galactic empires. We should be intercepting broadcasts with our massive radio telescope arrays. Yet, as we point our most sensitive instruments toward the distant stars, searching through the endless frequencies of the electromagnetic spectrum, we hear absolutely nothing. The cosmos is entirely silent. Consider the concept of deep time. The universe is approximately 13.8 billion years old. Our solar system formed a mere 4.5 billion years ago. This means there are countless stars out there, particularly red dwarf stars and ancient sun-like stars, that are billions of years older than our own. Imagine an exoplanet orbiting one of these ancient stars. If a civilization evolved there, they would have a head start of 1 billion years on human technological progress. What does 1 billion years of technological advancement even look like? Just a few centuries ago, humanity was crossing the oceans in wooden ships. Today, we have the International Space Station orbiting the Earth, and we have sent the Voyager probe beyond the heliopause into interstellar space. Now, project that progress 1 million or 1 billion years into the future. Such a civilization would have easily conquered the challenges of interstellar travel. They would have built massive fleets of generation ship cruisers, slowly but inevitably colonizing every viable star system in the Milky Way. In a few million years, expanding at even a fraction of the speed of light, a single civilization could completely colonize the entire galaxy. If they achieved this, we would see the undeniable evidence of their engineering. According to the Kardashev scale, a method of measuring a civilization's level of technological advancement, a Type II civilization can harness the entire energy output of their host star. To do this, they would construct a staggering megastructure known as a Dyson sphere or a Dyson swarm. These colossal swarms of solar collectors would completely enclose a star, capturing its radiation to power unimaginable technologies. If such empires existed, they would leave a massive footprint in the cosmos. A Dyson sphere would block the visible light of the star, but it would have to radiate waste heat back into deep space in the form of infrared radiation. Our most powerful observatories, like the James Webb Space Telescope, should be able to detect these unnatural infrared signatures glowing in the dark. We should see galaxies that have been artificially darkened or altered by advanced astroengineering. But as we survey the distant galaxies and the depths of the cosmic web, we see no alien megastructures. We see no artificial ringworld habitats. We only see the natural, undisturbed processes of stellar evolution. This brings us to the most chilling explanation for the Fermi Paradox, the Great Filter. Proposed by economist Robin Hanson, this theory suggests that somewhere along the evolutionary path from dead matter to a galaxy-spanning civilization, there is an incredibly difficult hurdle. There is a wall. A barrier of death that is almost impossible for any species to cross. The Great Filter acts as a cosmic Grim Reaper, systematically wiping out life before it can spread across the stars. The terrifying question for humanity is, where is this filter located? Is it behind us, or is it waiting for us in the future? If the Great Filter is behind us, it means we have survived an evolutionary bottleneck that billions of other species failed to pass. Perhaps the initial spark of life, the transition from complex chemistry to biology, is statistically almost impossible. Or perhaps the leap from simple single-celled organisms to complex multicellular life is the barrier. If the filter is in our past, humanity is an incredibly rare lottery winner in the universe. It means we might be one of the very few, or perhaps the only, intelligent species to ever make it this far. In this scenario, the empty cosmos is a vast, unpopulated frontier waiting for us to inherit it. But what if the great filter is ahead of us? This is the darkest and most horrifying possibility in modern astrophysics. It implies that the universe is teeming with life, and many species reach our current level of technological advancement. But then, they all hit the same impenetrable wall and are entirely annihilated. What could this future filter be? The cosmos itself is incredibly hostile. A sudden asteroid impact, a nearby supernova explosion, or a deadly gamma-ray burst could sterilize our planet in an instant, resetting the biological clock to zero. But the most dangerous threat might come from our own hands. As a civilization unlocks the fundamental secrets of physics, they gain the power of absolute destruction. The discovery of nuclear fusion and fission gave us the power to destroy ourselves completely. As we develop advanced artificial intelligence, engineered pandemics, and antimatter weapons, our capacity for self-annihilation grows exponentially. If the great filter lies in our future, then every time a civilization looks up at the stars and begins to build a radio telescope, their days are already numbered. They consume their planet's resources, trigger unstoppable climate collapse, or annihilate themselves in global thermonuclear war. They become a brief, fleeting spark in the dark history of the cosmos, fading away before anyone even notices they were there. This changes how we must view the deep space. The silence of the universe is not the peaceful quiet of an empty room. If the great filter is real, the observable universe is a massive, silent graveyard of failed civilizations. It is a cosmic tomb, holding the ashes of countless species that reached for the stars but ultimately fell into the abyss of extinction. And if we are not careful, humanity will be just another forgotten whisper in the dark. To truly grasp the horrifying reality of the dark forest theory, we must shift our perspective. We must stop looking at the cosmos through the lens of astrophysics or chemistry, and begin looking at it through the cold, unforgiving lens of cosmic sociology. If the Milky Way is indeed home to multiple instances of extraterrestrial life, how would these civilizations interact across the vast, terrifying gulfs of deep space? In the renowned science fiction work The Three-Body Problem, author Liu Cixin laid down two fundamental axioms of cosmic sociology. These are the unbreakable laws of survival in a crowded universe. The first axiom is simple but absolute: survival is the primary need of civilization. Everything a species does, every technological advancement, every cultural shift, is ultimately driven by the biological and societal imperative to continue existing, to avoid extinction at all costs. The second axiom is where the true nightmare begins. Civilization continuously grows and expands, but the total matter in the universe remains constant. We know that we live in an expanding universe, driven apart by mysterious dark energy, but the physical resources within any reachable stellar neighborhood are strictly finite. There are only so many habitable planets, only so many star-forming regions, only so much energy to be harvested from a sun. When you combine these two axioms, the universe transforms. It is no longer a peaceful frontier waiting for exploration. It becomes a zero-sum game of extreme cosmic proportions. In a universe where resources are limited and every civilization's primary goal is to survive, competition is not just likely, it is inevitable, and it is fatal. But why does this competition lead to absolute silence? Why don't civilizations negotiate, trade, or form alliances like nations do on Earth? To answer this, we must understand the most paralyzing concept in cosmic sociology, the chain of suspicion. Imagine two civilizations discovering each other across the cosmic dark. Let us call them Civilization A and Civilization B. Civilization A detects a faint signal from a distant exoplanet. Immediately, they face an impossible dilemma. They cannot know if Civilization B is benevolent or malevolent. On Earth, if you meet a stranger in a dark forest, you can look into their eyes, read their body language, and make a split-second judgment. In deep space, this is impossible. The distances are simply too vast. Communication is strictly limited by the speed of light. If Civilization B is located just 1,000 light-years away, a single transmission takes a millennium to arrive. A simple exchange of greetings would take 2,000 years. By the time Civilization A receives a reply, the alien society they are talking to might have fundamentally changed. Their peaceful government might have been overthrown by a hostile, militaristic regime. Because of this insurmountable communication barrier, Civilization A can never be certain of Civilization B's true intentions. But the paranoia goes much deeper. Even if Civilization A is entirely peaceful, they cannot know if Civilization B believes they are peaceful. Civilization B might look at Civilization A and assume they are a threat. Therefore, Civilization A must consider that Civilization B might attack them preemptively out of fear. This creates an endless, unbreakable psychological loop. I don't know what you think of me. You don't know what I think of you. I don't know what you think I think of you. In the complete absence of trust and the impossibility of rapid communication, the safest, most logical assumption is the worst-case scenario: every other civilization is a mortal threat to your own survival. Yet, a naive observer might argue, what if we discover a civilization that is significantly less advanced than us? What if we find a species that has only just developed basic telescopes, or is just sending their first astronauts into Earth orbit? Surely, a primitive civilization cannot pose a threat to an advanced empire capable of bending space-time and harvesting the energy of a black hole. Why not leave them alone, or even help them? This brings us to the final, most terrifying pillar of the dark forest theory, the technology explosion. In the grand timeline of the cosmos, biological evolution is incredibly slow, taking billions of years to mold single cells into intelligent beings. But technological evolution is not linear, it is exponential. It is an explosion. Consider human history. For hundreds of thousands of years, our ancestors hunted with stone spears. Then, in the mere blink of a cosmic eye, a few thousand years, we went from building the pyramids to splitting the atom, landing a lunar rover on the moon, and launching the James Webb Space Telescope into the cold void. Now, imagine an advanced civilization observing a primitive planet. They might see a species just discovering electricity. But the advanced civilization knows that the speed of light makes their observation dangerously outdated. If they are looking at a planet 1,000 light-years away, they are seeing that civilization as it was 1,000 years ago. In the time it took the light to reach their telescopes, that primitive species might have already experienced a technology explosion. They might have already mastered interstellar travel, unlocked the secrets of quantum physics, and developed weapons capable of shattering planets. Therefore, in cosmic sociology, there is no such thing as a harmless primitive civilization. A weak species today is a godlike threat tomorrow. If you discover another civilization, letting them live is the ultimate gamble with your own species' survival. You cannot risk the possibility that they will experience a technology explosion and eventually come for your resources. The logic is absolute, cold, and mathematically ruthless. If survival is the primary goal, and trust is impossible across the vastness of deep space, and every species has the potential for explosive technological growth, there is only one rational course of action upon discovering alien life. You do not say hello. You do not send a probe. You strike. You annihilate them completely, immediately, and without warning, before they have the chance to do the same to you. The universe is a dark forest. Every civilization is an armed hunter stalking through the trees like a ghost, gently pushing aside branches that block the path and trying to tread without making a single sound. Even breathing is done with caution. The hunter has to be careful, because everywhere in the forest are stealthy hunters like him. If he finds another life, another hunter, whether it is an angel or a demon, a delicate infant or a tottering old man, a fairy or a demigod, there is only one thing he can do: open fire and eliminate them. In this forest, hell is other people. It is an eternal threat where any life that exposes its own existence will be swiftly and mercilessly wiped out. This is the ultimate, chilling picture of cosmic sociology. This is the exact reason why our massive radio telescope arrays hear absolutely nothing. The silence of the night sky is not the silence of a barren desert, it is the terrified silence of a jungle hiding from a predator. Advanced, ancient civilizations do not broadcast their coordinates across the Milky Way galaxy. They do not send out welcoming beacons or construct massive, glowing megastructures that advertise their presence. They have learned the hard way that visibility equals death. They wrap their star systems in stealth, meticulously hiding their thermal signatures, dampening their electromagnetic emissions, and ensuring that no rogue signal ever escapes into the cold void of deep space. They survive by being invisible. They survive by being the silent hunters in the dark. While the rest of the cosmos hides in absolute terror, holding its collective breath, what exactly is humanity doing? We are the foolish infant crying out in the middle of the dark forest, holding a bright torch, shouting to the unseen predators, "I am here. I am here." For the past century, we have been carelessly leaking high-frequency radio waves, television broadcasts, and military radar signals out into the deep space. An expanding sphere of our electromagnetic noise is currently washing over thousands of nearby stars. But we did something even more recklessly dangerous. We intentionally targeted dense star clusters with the Arecibo message, actively broadcasting our exact biological makeup, our DNA structure, and our precise planetary coordinates. We have essentially shouted our home address into the abyss, hoping for a friendly neighbor to answer. And we did not stop at radio waves. We launched physical maps leading right to our front door. The Voyager 1 and Voyager 2 spacecraft are currently leaving the boundaries of our solar system, crossing the heliopause and plunging into the dark interstellar medium. Attached to the side of these probes are the golden records. These metallic disks contain the sounds of our world, human voices greeting the cosmos, images of Earth from space, and most terrifyingly, a pulsar map pointing precisely to the location of our Sun in the Milky Way. To humanity, it is a beautiful, romantic message of peace and curiosity. To a highly advanced, paranoid hunter lurking in the dark forest, it is a perfectly painted target on our backs. We have handed the executioner a map to our home. If the hunters are truly out there, quietly and efficiently eliminating the noisy, careless civilizations, what does a cosmic assassination actually look like? They would not use primitive lasers or nuclear missiles. A highly advanced predator, operating on the scale of galaxies, would weaponize the laws of physics themselves. When human astronomers observe a sudden, inexplicably violent supernova explosion or a blindingly intense gamma-ray burst originating from a distant galaxy, we comfortably assume it is a natural astronomical event. We classify it as the random, chaotic mechanics of a dying star. But what if it is not? What if a gamma-ray burst is actually the muzzle flash of a relativistic weapon, intentionally aimed at a planetary system to instantly sterilize it of all biological life? Such a beam of concentrated radiation would strip away a planet's atmosphere and boil its oceans in seconds, leaving behind nothing but a scorched, sterilized rock. What if the sudden, unnatural flaring of a supermassive black hole in the center of an ancient galaxy is not a natural feeding cycle, but a defensive mechanism or the industrial byproduct of a Type 3 civilization wiping out a rival sector? We look at the violent, chaotic forces of the cosmos and we see the blind hand of nature. But a darker, more paranoid perspective suggests we might actually be looking at an active cosmic battlefield. We might be witnessing the distant flashes of a silent war where entire star systems are casually and routinely erased to ensure the survival of the unseen masters of the dark forest. Every bright flash in the deep space might be the death scream of a civilization that made the fatal mistake of speaking too loudly. If the dark forest theory is the true reality of our cosmos, then humanity is currently living on borrowed time. When we look at the iconic pale blue dot photograph, capturing the Earth from space as a tiny, fragile speck suspended in a sunbeam, we usually feel a sense of poetic unity and peace. We see a vulnerable blue marble that needs protecting. But through the lens of cosmic sociology, that beautiful pale blue dot is something entirely different. It is an exposed target floating in an ocean of invisible predators. Our solar system is not a safe haven, it is a brightly lit clearing in the middle of a haunted, predatory jungle. For decades, there has been a fierce debate among astrophysicists and planetary scientists regarding the wisdom of METI, or messaging extraterrestrial intelligence. While listening passively with a radio telescope is perfectly safe, actively transmitting high-power signals into deep space might be the most suicidal endeavor ever undertaken by the human race. Prominent minds, including the late Stephen Hawking, have passionately warned against broadcasting our presence. They argued that any civilization capable of crossing the interstellar void to reach us would be vastly superior in technology, viewing us perhaps no differently than we view a colony of ants. If the hunters are listening, every radio broadcast, every targeted radar pulse, and every digital greeting we hurl into the universe is a reckless gamble with the survival of our entire species. We must ask ourselves a terrifying question: is it already too late? The radio bubble of human civilization has been expanding outward at the speed of light for over a century. This sphere of electromagnetic radiation has already washed over thousands of star systems in our immediate galactic neighborhood. If a hostile, paranoid civilization resides within 100 light-years of our sun, they already know we are here. They have heard our radio programs, they have detected our military radars, and they are currently calculating the trajectory of our solar system. The terrifying reality is that a relativistic kill vehicle, a weapon traveling at a fraction of the speed of light, could already be halfway here, quietly tearing through the interstellar medium, aimed directly at our pale blue dot. We would not see it coming until the very moment our atmosphere ignites. So, how does humanity survive if the Milky Way is truly a dark forest? How do we secure our future in a galaxy where visibility equals absolute death? The answer requires a fundamental shift in our dreams of the future. The classic science fiction vision of humanity building a massive galactic empire, constructing a glowing Dyson sphere around our sun to harvest its ultimate energy, and broadcasting our majestic achievements to the cosmos is a recipe for instant annihilation. A Dyson sphere is the ultimate cosmic lighthouse. It screams to the entire observable universe that a highly advanced, resource-hungry civilization lives here. Instead of expanding loudly, humanity must learn to expand silently. True survival dictates that we must become ghosts. Our immediate goal must still be to become a multiplanetary species, because a single planet is far too vulnerable to a natural asteroid impact, a catastrophic solar flare, or a targeted strike. We must pursue terraforming Mars, turning the red planet into a secondary refuge. We must construct a permanent, self-sustaining moon base hidden in the deep shadows of the lunar craters. We must establish hidden colonies beneath the thick ice of the Europa Ocean, using the icy crust as a natural shield against both cosmic radiation and the prying eyes of alien telescopes. But even mastering our own solar system is not enough. Eventually, we must pursue interstellar travel to ensure the long-term survival of the human genome. However, we cannot use massive, brightly glowing antimatter engines that would light up the deep space like a flare gun. We must design stealth generation ships, massive vessels completely disguised as cold, dead asteroids or wandering rogue planets. These silent arcs would drift slowly and invisibly through the dark interstellar space, powered by heavily shielded internal nuclear fusion reactors that leak absolutely zero thermal radiation into the surrounding void. We must spread our seeds across the galaxy without leaving a single footprint, hiding in the cosmic web, utilizing the gravity of dark matter to slingshot our silent vessels from one dead star to another. As we conclude this terrifying journey into the absolute silence of the universe, we must reevaluate our relationship with the night sky. The great silence of the cosmos is often viewed with a sense of profound loneliness and melancholy. We look up at the glittering tapestry of the Milky Way and feel an agonizing isolation, wishing for a cosmic brother or sister to speak with. But if the dark forest theory holds even a fraction of the truth, we should not fear the silence. We should revere it. We should be eternally grateful for it. The silence is not an empty cemetery, it is a heavy, protective blanket. It is the only thing keeping us alive. Every day that our radio telescope arrays detect nothing but the static hiss of the cosmic microwave background is a good day. It means we have survived another rotation of our planet without being noticed by the ancient, merciless gods of the galaxy. As we look forward to the distant, unimaginable end of the universe, moving toward the ultimate freeze and the heat death of the cosmos, Perhaps the ultimate victory for a civilization is not to conquer the stars, but simply to endure among them. To witness the majesty of the expanding universe, to understand the poetry of a supernova explosion, and to quietly observe the beautiful, terrifying mechanics of creation without ever disturbing the delicate, deadly balance of the dark forest. We are alone, we are vulnerable, and we are surrounded by an infinite, silent abyss. And for now, that absolute silence is our greatest savior.